Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
I'm Philip Emeagwali. The experimental invention of the massively parallel processing supercomputer that solves many problems at once instead of solving only one problem at a time, and its absorption into new computers and into new supercomputers is one of the computing industry's most hopeful narrative. Prior to the 4th of July of 1989, the naysayers within the supercomputer industry demanded that parallel processing adapt to them instead of them adapt to parallel processing. In the supercomputing community of the 1970s and 80s, the massively parallel processing supercomputer was greeted with skepticism and was ridiculed as a huge waste of everybody's time. The inventor is the troubadour of technological knowledge. The inventor of parallel processing is the troubadour of supercomputing. But unlike the troubadour that was the medieval lyric poet of the 11th to 13th centuries, who writes verse to music, the inventor of the modern supercomputer writes never before seen emails to a never before seen ensemble of processors that outline a never before seen internet that was never before understood as a global network of processors that is the fastest supercomputer de facto. One unexpected benefit of being a black and African inventor, and therefore forced to invent as a lone wolf, was that it enabled me to have a coherent vision that I centered on my new internet. In the 1970s and 80s, I developed a body of work in which the elements were disparate but yet fit together as one cohesive whole. That's a new supercomputer, and that's de facto a new internet. For instance, I discovered that what I learned or discovered in previous boards translated over in whole or in part, and that far more important, that I was retelling the same story of the motions of fluids that were governed by the laws of physics. I was the troubadour of supercomputing who translated a story in extreme scale computational physics and translated it from the blank storyboard to a story in modern mathematics on the blank blackboard, and translated that story in a never before seen calculus to a story in extreme scale algebra, and to a story that resulted in my execution of immensely computation-intensive floating-point arithmetical calculations executed on the motherboard and translated that story on the motherboard to 64 binary thousand stories across motherboards, and continued to translate those stories to the boardrooms, to the classrooms, and to your living rooms. Amongst research supercomputer scientists, that style of speaking and thinking was distinctively mine. An artist often uses the same style to portray different subjects. An artist may be an impressionist, like the late 19th century Frenchman Claude Monet, or a surrealist, like the early 20th century painter Salvador Dali, or a modernist, like the 1920s and 30s painter Henri Matisse, or a sculptor, like the 20th century Ben Enwonwu of my hometown of Onitsha, Nigeria. I am an extreme-scale computational physicist that uses the laws of physics to digitally replicate the global motions of fluids that enshroud the Earth. I digitally replicated those motions across my new internet. That's a global network of 65,536 equidistant processors that encircled a globe. That's my metaphor for the Earth. My quest for the fastest supercomputer was a 16-year-long journey that began on June 20, 1974, and began on a sequential processing supercomputer that was at 1800 Southwest Campus Way, Corvallis, Oregon, United States. My experimental discovery of the fastest supercomputer ended on a parallel processing machine in Los Alamos, New Mexico, United States. Los Alamos is a quiet, small town that's often referred to as the capital of supercomputing, but is better known as the birthplace of the atomic bomb that was dropped in Hiroshima, Japan. When I began supercomputing on June 20, 1974, I lacked clarity on what my new internet or global network of 64 binary thousand processors, that's a parallel processing machine, was. My early vision of a small copy of that new internet was a mere idea, a small seed of an iroko tree, instead of the grown 160-foot tall iroko tree that it became 16 years later. I began in 1974 with a semi-abstract theorized hyperbole internet. That new internet was a global network of computers. That new internet evolved from one CPU or processor to across 16 years to become a very realistic new internet that used the cube in the 16th dimension as its metaphor. I experimentally discovered that new internet in the 16th dimension and discovered it as a global network of 2 raised to power 16 or 64 binary thousand processors, or as a global network of 65,536 computers. I was asked, when the games are over, how do you want to be remembered? I want to be remembered as the supercomputer inventor that connected those dots or vertices, so to speak. I want to be remembered as the supercomputer discoverer that told the cohesive story and discovered those internets as de facto cohesive computers that are the fastest.
Insightful and brilliant lecture.